George, I'm very glad to say, has stayed home because he has COVID. But he is my engineering director counterpart. So please don't ask me any horrendously complicated questions at the end. I may be answer some of them, but I was going to be relying on him heavily. So just bear that in mind if you want to ask any questions. So internal developer platforms, or IDPs, have taken the developer world by storm in kind of recent years as more and more companies work to minimize the cost and the complexity of enabling their developers to self-serve. So I will be talking about what an IDP actually is, the driving forces, or some of the driving forces at least, behind the adoption of IDPs and the aspirations to build them. And I'll also be explaining why MongoDB Atlas, our developer data platform, is such a great complement to an IDP. Then, in the spirit of meeting developers where they're at, I'll be talking you through how you can actually incorporate Atlas as the data layer in your IDP using any of our DevOps integrations. So I'm going to start off with a little anecdote about a fictional company to help set the scene for why IDPs have grown in popularity. So at this fictional company, Leafy Inc., there were many developers who wanted the same thing, to develop best-in-class software to their customers. Not a surprising aspiration. They felt like their developers were being slowed down, waiting for central teams at the company to provision or update their infrastructure. Like a lot of companies, they'd made the shift in recent years to jump on the DevOps bandwagon. And that meant shifting left and enabling developer self-service by transitioning some of the configuration for infrastructure kind of left to the developers. Raise your hand if you think this magically solved their problem. They ran into quite a few issues that actually slowed them down when they did this and shifted left. And it frustrated their developers in new and painful ways. They had given their developers a pretty free rein in managing their own systems, assuming that it would result in massive time savings. But in reality, it led to a lot of complexity. Their developers needed to have a much deeper understanding of the infrastructure, how it worked and how it was configured. And this led to a lot of cognitive load in doing their jobs. Cognitive load is the amount of mental processing needed to complete a task, and these developers were facing a lot of it, meaning they had to spend a lot of time worrying about the things that they wanted to take for granted. This results in a loss of productivity, slower delivery of new features, and perhaps most importantly in the long term, a significant drop in developer happiness. The company found that with greater freedom came more permissions for a lot of people, which created security issues. This, coupled with the difficulty of auditing what was being done and how it was being done, threatened their compliance standards. And all of this resulted in unwanted overhead of cost, risk, and general dissatisfaction. In short, they really needed a solution for all this complexity. And they needed it to be a holistic approach and a solution to the problem and it wasn't long before they settled on developing their own IDP. So the idea is that an IDP creates a level of abstraction from the complexity to reduce cognitive load. An IDP provides consistent tooling and ideally processes across engineering teams, which helps with onboarding and collaboration and potentially retention. Standardized workflows simplify the self-service, but without the massive burden of actually maintaining and managing the infrastructure kind of more directly. Maintenance and development of the IDP can be separated from the application development, meaning that there's less conflict to work on the IDP, and any improvements made to it with centralized teams benefit all. And then, through reduced permissions for most developers, the security risk was lessened considerably. And finally, allowing developers to focus on what they've actually been hired to do means you have happier developers, they're more engaged, and they're more likely to stay, which means you keep the good people. Leafy had seen a lot of pictures like this one, and it was pretty intimidating. They'd heard about other companies trying to build it all at once and floundering, and they knew that each of these boxes essentially represented myriad options that they could potentially choose, and then that they have to plumb in. So they decided to start by tackling one thing at a time and start with good foundations. And almost every application they had needed a data layer. You can probably already see where this is going. They had lots of different needs. They needed a transactional database, a cache. They needed full text search, stream processing, a database for time series data, and even a vector database. But as part of the problem they'd seen before, there was sprawl of different technologies that needed to be tested, monitored, maintained, and secured. And that was a completely fragmented developer experience that they'd seen before. And so they wanted to choose one option to provide as many of these as they could, especially since working with data was one of the things that developers reported was one of the more complicated aspects of building applications and one of the more complicated infrastructure elements that they'd had to deal with in the past. So hands up if you'd guessed that they were already going to use Atlas. All of us at MongoDB are probably undeniably biased, but Atlas is a great natural fit for an IDP because it serves as a data platform that can easily fit into almost any application stack. It's fully managed. It abstracts away the complexity. You're not having to manage the infrastructure layer at all. Not only is it usable through an IDP and very easily usable, and we'll get to that in a minute, there's less overhead for the business as a whole through using this as a managed service plumbed into their IDP. And so all of them could rest assured that their data layer would stay up and running thanks to the availability to deploy in 100+ regions across the major cloud providers. And they knew they could confidently run their most important database workloads in Atlas thanks to automated operations and the ability to integrate into their IDP deployment workflows. Oh, should have been clicking. Cool. So rather than having to choose between different data tools, Atlas allows them to address a breadth of data use cases, and our developer data platform addresses transactional workloads, all of the use cases basically that I mentioned just now. And this prioritizes an intuitive developer experience and helps the security, resilience, and performance at scale. We're about to kind of start getting into the actual options that we offer for Atlas, and then I'll be going through how some of them work, getting more from the theory into kind of the practical. But Levy's team had decided that Atlas was their best choice. The range of options save the developers from having to learn any new tooling in order to manage Atlas, and that's because we support a range of tooling that's already very prevalent in the industry. All of these tools at the bottom are built off the Atlas admin API, which we've got at the top, which provides a RESTful interface for programmatically managing Atlas. You can use the API directly or via our Go SDK to actually plumb it into your IDP however you need to. But many customers leverage this tooling at the bottom that we provide to use in a more developer-native way. For example, let's say your IDP is underpinned by Kubernetes. We've got the Atlas Kubernetes Operator. If you're very prevalent Terraform users, we've got the Terraform Provider. We've got the CloudFormation support and AWS CDK support. And we've also got the CLI, which is great if you kind of want to use it manually for one-off tasks, or you can potentially script against it. So we're going to start with a look at our Atlas Kubernetes Operator. At the moment, it's one of the slightly less used or less known ones. It's a couple of years old now, but it kind of relies on you running your applications in a Kubernetes environment to actually be able to take advantage of it. But Kubernetes has become a very common foundational layer for many IDPs, thanks to the benefit of running containers, which are very well aligned with microservices, another popular kind of trend in the industry. And Kubernetes also provides huge automation and flexibility. One of the most significant developments in Kubernetes has been the kind of the extensibility that particularly operators take advantage of. And so an operator is a service built to extend the default control plane of Kubernetes to support the custom logic of a specific application. In our case, Atlas. Operators use custom resource definitions that define new and custom resource types, and then you create those custom resources along the lines of the schemas that the definitions provide. And you're effectively managing resources running somewhere in a declarative format. Really good for kind of infrastructure as code. Operators can also handle more than just the infrastructure. They can provide custom logic for a specific application, so they can make things easier that otherwise would involve some toil for the users. And although a lot of operators manage services within Kubernetes, there are more and more operators coming about that can manage services running outside of Kubernetes, like Atlas. And in this way, they're effectively kind of a proxy for the configuration that you deploy into Kubernetes. And typically, they're calling APIs to actually enact your declarative configuration to make it so. So the operator is built to simplify and integrate into Atlas, into your Kubernetes IDP. It allows your developers to use the same tooling and processes to manage Atlas as they're using to run applications in Kubernetes. The Atlas operator picks up the configuration in the custom resources, applies it through the Atlas admin API, and it saves your users from necessarily onboarding to the API, understanding all of the finer details. It also allows us and potentially you, providing the operator out to your users, to abstract the users away from some of the finer details. There's all sorts of options in Kubernetes to abstract even further than we already do with our custom resources, and potentially only expose a minimal set of options to your developers to enable them without necessarily loading them up with complexity. So very low cognitive load. This makes it great for developer self-service, which is obviously key to an IDP, and it's largely the whole point, developer self-service with minimal complexity. The IDP could even include centrally managed templates for Atlas resources that developers can use. It's really easy to generate templates and kind of provide those out to enable the developers. Because operators in general, and in particular our operator, reconcile frequently, ours reconciles at a period of 3 hours, it's effectively checking the configuration in Atlas and ensuring that the configuration still aligns with the configuration that you've got in your declarative resource. And in this way, it effectively prevents configuration drift. It means that any changes made through any unauthorized interfaces, or perhaps authorized ones, would technically get overwritten by your source of truth, which is the custom resource. The operator supports any CNCF certified flavor of Kubernetes, including the 3 major clouds versions of Kubernetes that are on offer. It's been in development for about 4 years now and generally available since June 22. So we've reached the actual demo portion, and I'm going to show you how easy it is to use the Atlas Kubernetes Operator with common IDP tooling before I move on to one of the other tools. Effectively, I'm going to show you how to leverage Atlas for your database as a service in a Kubernetes IDP. I'm going to show you one of a few ways to install the operator, and then use it to actually create a deployment. Then we're going to build it into a GitOps interface using Argo CD, one of the most popular kind of CD tools around Kubernetes, to bridge the gap between the IAC files in your repo, in your Git repo, and Kubernetes. And this will make it really easy to see how developers can manage Atlas's declarative configuration within their existing repository alongside their application code. And it also standardizes the workflow through this GitOps pipeline that they're probably already using to deploy into Kubernetes, which in turn cuts down their expertise needed and the permissions needed for individuals in Kubernetes. And then I'm going to show you how easy it is to connect your application to the database using a Kubernetes secret that the operator automatically generates for database users created by the operator. So, the operator can be installed in a few different ways. Oh, sorry, I shouldn't have clicked play yet. I've got a little bit of preamble. Very little though, don't worry. The operator can be installed through kubectl. It can be installed through Helm charts or potentially automation scripts. But in this case, we're going to use the MongoDB Atlas CLI. It's a tool we recommend all Atlas users have anyway, because it's great for kind of one-off tasks. But it also makes the installation and configuration of the operator very simple by automating much of the setup. So by installing the operator through the Atlas CLI, we not only install the operator in the Kubernetes cluster that you are currently connected to with kubectl, but all the necessary setup happens, such as creating new API keys for the operator to manage Atlas resources. We can see the operator is starting up in the Kubernetes cluster, and looking into Atlas, we'll be able to see that the API keys have been created for the operator to use, and we'll see the API keys stored in Kubernetes in a secret that's been created by the CLI. Now that the operator is installed, the next step is to actually set up an Atlas project. It's a pretty simple custom resource, and it's defined in YAML. And all we have to do is use kubectl apply to apply that into Kubernetes. The new custom resource has been created, and under the hood, the operator has also read the resource and created the project in Atlas. There we go. We're now ready to deploy our first cluster to Atlas through the operator. And in a simple YAML format, we can also define the cluster configuration, seen here, including the cloud provider, the instance type, and the region that we're actually going to deploy into. You can create much more complicated clusters, including sharded clusters and so on, but this is a relatively basic one. We'll use kubectl apply again to actually apply that into Kubernetes. And once that's applied into Kubernetes, the operator will pick that up, respond to that resource, and the MongoDB Atlas cluster is now being created in Atlas. So moving on to more of a platform IDP interface. We're going to use a GitOps workflow that uses Argo CD that enables developers to manage the configuration via their Git repo. Argo CD is also pretty simple to install. We'll be creating a new namespace for all the Argo components to run in, just to keep them separate. And we're going to be using an install script that only takes a single command, and a few seconds. We can see here all the Argo CD operator pods starting up. So next thing we need to do is create an Argo application. That's what we're defining here. We're going to define the Git repository that the Argo CD will be watching to find our new infrastructure as code files, as well as the destination Kubernetes clusters and namespaces for resources to be deployed in. And then we can connect into the UI, and we can actually see that all set up. We can see our database as a service application there created and monitor its status. So to deploy an Atlas project, we're going to use pretty much the same project resource. Very, very similar, slight name change. Instead of using kubectl this time, we're going to push it into our Git repo. Argo CD will be watching to find new IAC files, and it will apply that to the destination Kubernetes cluster. And there we go. That second one there has been created via Argo CD. Now, again, the Argo CD the operator will have picked up the changes and will actually apply that into Kubernetes. And from there, apply that into Atlas. And from there, we can then move on to creating an Atlas deployment. Again, we're going to push that, pretty much the same kind of deployment, push that into the Git repo. Again, Argo CD will automate that into Kubernetes. And both in Argo CD, we'll be able to see the cluster. And in here, we'll be able to see the project and the deployment within it being created. Now that we've streamlined the deployment and management of new databases, we'll see how easy it is to connect applications to those in the Kubernetes native way. And we'll be creating a new custom resource called Atlas Database User in order to manage the database access. Each database user is essentially just another file. What we've done here is we've created a secret for the user password. We're going to specify that at the bottom there. When we create this Atlas database user called GitOps user. Again, we're going to push that to our Git repo. And again, because we've got Argo CD set up already, that's going to automatically apply that into Kubernetes. And we'll see it picked up there, the GitOps user. When that user is created in Atlas, we are auto-generating a new secret in there. And if we look at that secret and kind of output it in the right way, we can see the connection string there. The creation of this secret is what makes it really, really easy to actually connect an application to it. And here's a really, really simple application we're calling Hello Atlas. And basically what we're doing is, as an environment variable, we're pulling in the connection string from that secret. This all makes it really, really easy to actually connect your application up to your Atlas database and give your application access to the deployment you've created. Cool. That application's just starting up, but it will have started by the time we do this, and we're pulling the logs, and you'll be able to see here at the bottom a successful connection prompt showing that we have successfully connected to that deployment. So that's the end of the demo, and you may have been expecting fireworks, but actually the good news is that when you don't get fireworks in this kind of situation, it's a good thing. So now we're going to move on to look at a slightly different area. Still infrastructure as code, but Terraform, CloudFormation, and AWS CDK. Some of the other options that we support for programmatically managing Atlas. Each of these options enable us to meet developers where they are and give us an option, give you and all of our customers an option to leverage tooling that your developers may already be familiar with and be using on a day-to-day basis anyway. Our HashiCorp Terraform Atlas Provider enables Terraform management of Atlas, unsurprisingly, and it's great for users who already know HashiCorp Configuration Language, or HCL. This particular provider is probably our most popular programmatic interface at the moment. It's in the top 10 of all Terraform providers in the Terraform Provider Registry, and it's #1 in the database category. The AWS CloudFormation resources are newer, but they're great for customers who have a tight coupling to the AWS ecosystem. Then we've got the CDKs, the AWS CDKs for Terraform and CloudFormation. These provide development kits for defining cloud infrastructure in a developer's native programming language, like Java, JavaScript, Python, C#, and Golang. AWS CDK, in particular, can save developers a lot of time and cognitive load. One of the biggest benefits of CDK resources is that they reduce the amount of code actually required to manage Atlas resources. So if you take a CloudFormation example, configuring Atlas resources, although it's relatively straightforward if you're familiar with CloudFormation, Atlas Basic as a CDK resource is a level 3 resource that produces the same results for 100 lines of code rather than 300. So it's kind of an abstraction to save that cognitive load that we talked about earlier. Using languages that developers know and writing less code obviously reduces the cognitive load, and it also reduces the chance that there's bugs, and it reduces the level of effort needed to maintain it. So this allows your developers to write less and do more with AWS CDK. We've got a couple of customer success stories of where they're benefiting from our infrastructure as code tooling. Okta, for example, they're using Atlas Vector Search via Terraform. And one of the managers there reported that MongoDB Atlas Terraform Provider takes administration away from their teams, and the developers are much happier. That's our end goal at the end of the day. Otto shared that they'd opted for MongoDB Atlas CloudFormation resources because they're easy to use, familiar to the developers, and helped them to scale to meet the needs of their business. So now we're going to take a little look about how you actually use the CDK. And there's a few simple prerequisites here. You need to have an Atlas account, which you can optionally create, by the way, via the AWS Marketplace listing. You need to create MongoDB Atlas programmatic API keys for access to the API, essentially. And you need to install and configure the AWS CLI and the Atlas CLI. So with the prerequisites complete, there's a series of 7 steps to deploy your first Atlas cluster via CDK. So first, we're going to run npm install AWS CDK, and that installs the AWS Cloud Development Kit globally. It can take longer in reality, but as you can see, it's already installed here. And this is what's needed to actually define cloud resources using familiar programming languages. Then we're going to run CDK bootstrap to tell CDK which AWS account to use, the region we're running in, and behind the scenes, this sets up resources in AWS that are needed for CDK usage, including an S3 bucket. Now we're going to run CDK init to create the new CDK project. Specifically in this case, we are going to use TypeScript. Effectively, this sets the groundwork for defining the infrastructure as code. It's a weirdly long delay. To gain access to the various MongoDB Atlas resources we offer, we're then going to run npm install AWS CDK-resources-MongoDB Atlas. This adds those resources to your CDK application to enable management of MongoDB Atlas from your CDK code. You can find those resources in our AWS CDK resources repository, along with the samples that we provide. And we're actually going to use one of these samples now to create the Atlas basic deployment that we talked about just now, that does in 100 lines of code what 300 lines of CloudFormation would do. So we're going to copy that into the file in the lib folder in our project in VS Code. Using our samples obviously gets you off to a great start. We're going to update the class name here to replace the name that was used in the sample with the name of this lib file in the CDK project we created in VS Code. And next, we're going to do a diff. This is an optional but useful step that allows you to compare the current CDK stack with the deployed stack, and it will show you what will be created, deployed, or modified. Arguably slightly more useful if you've already got something there, but still very useful to know what is actually going to be done and what's going to be created. And you can see here we're going to create a project, a cluster, database user, and also a project IP access list. Cool. Then we're going to do CDK deploy to actually deploy what we've created and actually apply it in action. Cool. Skipping ahead a little bit and jumping over into the MongoDB Atlas UI, we can see that the project is still being created. But if we go to database access, we can see that the user has already been created there for us. And jumping over into network access, we'll also see the IP access list created using the IP address that we specified. So with a minimal amount of configuration, we are creating all of these resources. Skipping ahead another couple of minutes while the deployment finishes off, we can see that the cluster has now been created, and it's ready to connect your application to and begin building. If you prefer a written copy of that, we've got a great blog post that guides you through this. And you can just Google the title here. And that's pretty much it. So as you've heard, Atlas is a brilliant addition to an internal developer platform, thanks to the high automation, low management overhead, and its tooling optimizes the developer experience thanks to the range of integrations that we offer that help reduce that cognitive load that IDPs are typically looking to tackle. There's nothing to stop you more than using more than one of our tools, and actually we have a number of customers who are doing that, because you can empower different development teams based on where and how they're running their applications. Some might be running in Kubernetes, some might be running in AWS, some might be running elsewhere. But using Atlas is kind of a commonality that provides a lot of extra functionality. And this tooling allows them to use the tooling that is most native to them. As we said, the Atlas Kubernetes Operator is a great choice if you're running Kubernetes. It allows you to reuse that tooling. Lastly, the resources that we provide enable simplified management through declarative configuration, and it abstracts developers away from that complexity. On the other hand, Terraform, CloudFormation, and CDKs are a great way when your developers want to use an interface that they're already using across a range of systems with infrastructure as code. CloudFormation and AWS CDK are AWS specific, but Terraform isn't. And any of these tools can help simplify the management and enhance reproducibility across your applications for your developers. And all three of these, and also the Kubernetes operators, are well adopted, well used, and I would like to say well loved. Terraform in particular has a very large community and ecosystem, extensive documentation, great modules and CDK resources, and plugins that can help accelerate development and deployment. And that is it. If you would like to find out more about any of our programmatic tooling that can be used with your IDP or just to reduce cognitive load for your developers regardless of whether you're building an IDP or not, you can find out more via this link. I really would love it if you could give any feedback. We're happy to tailor future sessions like this to what you guys are interested in. So please rate the session, please leave any feedback, and thank you very much for coming.